This lesson is going to look at something called imaginary numbers. Imaginary numbers are necessary when we're looking at the square root of negative numbers, because when we're looking at square roots, remember the square root asks you what number times itself gives you the number underneath the square root sign. When you have a negative number underneath the square root sign, you cannot have any real number that multiplies by itself to give you that negative, because a positive number times itself, so positive times a positive, is still a positive number, and a negative number times itself, or a negative times a negative, is also a positive number. So that's where the imaginary numbers come in. So if I were to look at the square root of negative 36, I could break that down into the square root of positive 36 times the square root of negative 1 with the square root property. The square root of 36, we know that we can simplify to equal 6. But then we're looking at the square root of negative 1. The square root of negative 1 is equal to the imaginary number I. So I could say then that my simplification process for the square root of negative 36 simplifies to 6i. So let's take a look at some more. If I have the square root of 28, or negative 28, plus the square root of negative 75, in order for me to add those, I first have to make the number underneath the square root sign into like terms. So if I were to simplify the square root of 28, I could say, using my biggest perfect square, would be 4. So it would be the square root of 4 times the square root of 7 times the square root of negative 1 plus, and if I were to do 75, it would be the square root of 25 times the square root of 3 times the square root of negative 1. So some of these things we can do. So I want to focus on each side separately for a minute. So I'm focusing on the side on the left. I can do the square root of 4, which is 2, and the square root of negative 1, which is I. And then on the side that we cannot do the square root of 7. So that would simplify to 2i square roots of 7. On the right-hand side, I can simplify the square root of 25, which is 5, and I can simplify the square root of negative 1, which is I, and then I cannot simplify the square root of 3. Now, my like terms, I do not have any underneath my square root sign, because on the left it's the square root of 7, on the right it's the square root of 3. So as far as I can go is 2i square roots of 7 plus 5i square roots of 3. Now let's take a look at this. We're looking at I2 powers. So I squared means I times I, or the square root of negative 1 times the square root of negative 1, which is equal to negative 1. I cubed equals I squared times I, so negative 1 times I, or negative I. I to the 4th power equals I to the cubed times I, or negative I times I, which is equal to 1. And then I to the 5th power is I to the 4th power times I, or 1 times I, which is equal to I. So what happens is, if you look at this, this is a pattern that keeps repeating. So my pattern is that I have I, negative 1, negative I, and 1. And then if you notice, it repeats itself again. So this is useful because sometimes you might be asked something to the effect of, I don't know, and I'm just making this up, but I say to the 50th power. You don't want to necessarily go through the entire pattern over and over and over and over again until you get to the 50. So what you can do is, because it repeats in 4s, you can take the exponent, the 50, and divide it by 4. So if I'm dividing it by 4, 4 goes into 5 once. I subtract 4, I'm left with 0. Or I'm sorry, I'm left with 1. And then I bring down my 0. That's where I got the 0 from. And then 4 goes into 10 twice. That's 8. I subtract, and I have a remainder of 2. This is where I'm stopping. I'm stopping with my remainder of 2. My pattern that we had, remember, was I, negative 1, negative I, and 1. So when I have a remainder of 1, my answer is I. A remainder of 2, my answer is negative 1. My remainder of 3, my answer is negative I. And if I have no remainder, then my answer is 1. So because I have a remainder of 2, I to the 50th power would be equal to negative 1.